Hello, can you hear me? Hi, my name is Vaagn, and this talk was prepared by my colleague Tigran and me. Tigran couldn't make it. Who we are, both of us work for Qualys. We do break stuff, we do fix some stuff too. Both are interested in time travel and are trying to try, meaning swimming, biking, and running. What is the talk about? The talk is about yet another denial of service method and some protection against it. We'll talk about the method, the tool, we'll go over some statistics, and then usage possibilities. Why? Why do we do that? Because we wanted to buy a time machine, as you see in the picture. You could buy one on eBay, but it's not really functioning. So we decided to make our own. And this machine works, and it does do only one thing. So what it does, it kind of sends you a message from future you telling that you succeeded to take the server down. Simple. That was a joke, actually. So a little bit of taxonomy on denial of service. So basically, two major types. One type is striving to crash the system, degrade the IT infrastructure, basically on a more or less system level. And then there are resource consumption attacks on a network layer, infrastructure device resource exhaustion, and a little higher level up, OCI levels 4 and up. But we're going to talk mostly about application layer denial of service attacks, layer 7, and most probably business logic layer, which is out of the OCI. So few classical applications of DOS and DDoS. Old methods of DOSing were mostly just DOSing blindly, basically doing get flooding. And some advanced guys decided that they're going to do that from multiple bots, and that's the DDoS that we see every day. The cons of this system are that you don't have feedback, and it's near symmetrical load on client and server if we are talking about non-distributed methods. Some newer, smarter bots came out 4 or 5 years ago. Things like slow LoRi, slow HTTP put, slow HTTP read. Some cases of PKI abuse, re-establishing the session or doing a handshake over and over, and, abusing the PKI on the server side. Some smart SQL wildcard injections that will overload your database, and also with advancements of WebSockets, there are newer vectors for denial of service. Mainly, WebSocket connection being persistent lets you faster and easier drain the server resources, sockets, or file descriptors. As I told a minute ago, some exotic layer 7 attacks based on DB wildcard usage, if used cleverly, could lead to overload on a DB. And there are these above layer 7 attacks, the attacks on business logic, where you don't take out the HTTP server, memory pool, or connection pool, but you are attacking the business logic by putting too many things in a cart and some other things that will render the service useless. So what is our proposed method? It's nothing else but get flooding. But compared to standard get flooding, we are doing some pre-attack analysis and then defining which resources should be attacked. So our method is not one of the new slow HTTP post or slow HTTP get attack methods. It's not trying to exhaust the connection pool or file descriptor pools of OS or Apache server. And resource consumption in a case of client server, if the client is not a full-blown browser, is asymmetrical by nature. We're just trying to enlarge that divide, making a server suffer more for any given number of connections. So what is our method? So the tool basically goes over your website, it spiders over and finds all the resources it could find. It's an easy spider, nothing sophisticated, and if needed, I will show you later, you can feed in crawl data from a different crawler. You don't have to use our internal crawler. So then once you have the list of resources, you would calculate the average speed of the transfer, which we think is going to be constant for average resource, the resource that doesn't require lots of calculations or doesn't load the DB much. And resource size is not significant because we are striving to keep a few connections, but with each connection we're trying to load the server as much as possible. So the only thing left for us is the transfer rate that we think correlates to the load on a server if the data is normalized. So here on this slide, we see the distribution of normal resources for an average website. And some slower resources drop into a totally different bunch. And our goal is to find this slow bunch and push them as much as possible. So what was done is just to calculate the mean of download speed of all the resources, and then we throw away all the resources that are fluctuating a lot, which don't have a standard deviation that meets our requirements. And that gives us more or less good confidence that whatever we found is precise. So here we have 4 quadrants of the speed and standard deviation distribution. And we are interested in a quadrant on the left lower corner where the standard deviation is low and speed of transfer is low, which means the resource is most definitely, because of the standard deviation, most definitely slow. And if you hit those resources, you are guaranteed to generate more load on the server, unless the server is fooling you and posing as a slow, setting some resources to pose as slow. Time for a little demo. So here we run our tool, with a depth of 3 for crawling, and it went through, and on a local host, of course, this is not a real application, found resources that have various loads, and these are the loads. It's not quite visible, and these are the speeds and deviations on the right side. So the smaller the number, the higher is the possibility that this resource is going to be hard on a server. The tool produces XML that you can feed to any other tools, or it can take in XML with list of resources and play with them. Here is a little bit of data visualization based on the results coming from the tool. My colleague who made this demo and also helped a lot with writing the code, he loves this data visualization tools, so he also has this crawl graph generated from the XML. So this is part of the tool, comes with the package for people to play with. Okay, so next thing, we're gonna crawl a specific CMS called Concrete, again with depth of 3, count of 10, and that will generate results where we see some resources being very slow. It gave out top 10 of the resources. Some of them are really slow. And now we can take in the XML that it generated and run it 100 times, stress testing the server. And of course, this is only one thread running. You could, let me pause it here. So what it did run with a couple of them running in parallel, and it tried to see what happened to the load and standard deviation when it is trying to stress the server by running it in parallel. This is, of course, not useful because it's running on a local server. But I will come back to that theme of stress testing it with few parallel threads and seeing how the service degradation appears as an additional step for this method. So here we are trying to run 10 threads of, basically 10 instances of the tool. In this case, 5, I'm sorry. This is an easier demo. This particular CMS utilizes almost 100% of the CPU, server CPU, if we run even 5 parallel requests at a time. So here on the left corner, we have the client console. This is the top CPU usage of the client, which is already 8% to start with because the UI is running here. And in the top, you see the server, which is quad-core i7 with lots of RAM. So as the clients start, we see the CPU jumping up. It's now only about 1% idle, only running 1 to 3% idle, only running 5 parallel clients. All right, enough of the demo. So as we saw in a demo, it's easy to take down a server even with the regular good old Git. You just need to know which resources to push. This is nothing new or exciting. We just want to rehash the fact that you need to pay attention to resource consumption on your web apps. So as an advanced topic, we are going to work on trying to figure out what really happens to a server if you do parallel stressing by looking at what goes on with those numbers like the speed and standard deviation. This is not done yet. So that's probably enough about the simple tool. Let's try to figure out what can be done to defend our web apps from it. So standard things would be using load balancers, having more servers to serve more clients. Another good approach would be to use the tool or similar tools to identify CPU or DBU hogs on your web app. And then Apache configurations could help. We'll go through them in a couple of minutes. Apache with its standard configuration, with its standard methods of configuring, probably wouldn't fight with it, but there are many modules that will help us. So load balancers usually all the vendors that we talk to, they have some kind of solutions against get floods by rate limiters and filters of unusual traffic. Those things usually work for most of the time, but if the person performing the attack is smarter than the load balancer, which is usually a case, if we talk about persistent threats, then they could do, if they find the threshold, they could do attacks right under the threshold, or if there are filters and the attackers understand how filters work, they could circumvent those. Some commercial denial of service protection services could help here. Again, they work on using limiters. Those also have the same issues as the commercial devices, security devices that you could buy. Some of those commercial cloud-based denial of service mitigators also have more security-like protections against SQL injections and XSSs. The problems with those are they are mostly expensive, and we talked to a couple of customers of those services, and one of the complaints was it's really hard to tune the system so it doesn't mess up the user experience while protecting against the attacks. It's really hard to balance that. And there was a very interesting talk this year at Black Hat, I think, about universal denial of service attack mitigation, the bypass of those commercial systems, which this paper finds all kinds of problems, mostly easily exploitable. So what can be done with our tool is to basically use it for as a QA tool. And with some manual tweaking, if the business logic requires steps to go through because the tool itself can't do it, you could find the problematic resources and further with the development of the tool, if we can implement this parallel stressing and measuring of the degradation, we will have even more confidence and we can pinpoint to a hog resource more easily. So we did run some tests on the systems that we tried to protect using off-the-shelf Apache modules. First, the baseline was just running it on a Apache without any protection enabled. The server is i7, 4 cores, 8 gigs. And as we saw in a demo, we saw 3% of CPU utilization on a machine, but that wasn't obvious from there, but we measured it once without UI. 3% on a machine, client machine, where the CPU on a server was 98 almost all the time. So what can Apache do without any additional modules? Mostly nothing. So that's why we tried to find some help from outside. Some good choice would be, or first choice would be mod security. Mod security has some ways of protecting against denial of service. Again, with having IP or with using some filters like source IP based limiters. This is good, but it's not ideal in some cases for large corporations or places where people see lots of diverse traffic coming from one IP. The tool would be fooled. And then it's possible with mod security to write a more complex and advanced protection against denial of service where we could identify internally in the server the regular flow of a web application. And when we see the out of ordinary flow, let's say an attacker pushing on contact us over and over without even going to the main page, those filters would be a bit more smarter than just rate limiters. Another module that we found and tested was pretty useful. Again, it's an IP-based limiter. You set it to some limit per IP, and it cuts down the CPU usage on the server right away. Again, problems are it's very crude, and you need to tweak your number of the limit you set. Another module is the mod QS, a bit smarter than the previous one. Works pretty well and basically does the same thing a bit more in a bit more smart way. Another bit more advanced module was this bandwidth share. This is not straight filter per connection or filtering based on sources, but it has some thresholds that lets you go over a bit, and then it has this concept of credit and debt. So a pool of IPs can go deep into debt up to some level, debt being the number of requests it makes, and if it goes on and overflows its debt, so after that it gets cut out right away. Basically, as tricky my explanation and unclear my explanation was, almost that tricky and unclear the setup of the module is. There was this one obscure module that we found, couldn't really make it work, and we got angry. That's why this green angry man is in a corner. And our favorite is the mod evasive. Which has the same methods that previous modules, but it's more tolerant to larger connections and will do almost same as the bandwidth share without this tricky setup. It's much easier to set up. So if we are trying to have more or less universal solution against denial of service attacks, we would also think about detecting from different kinds of slow attacks, slow lorries, slow read, slow post, and such things. So mod evasive would be helpful to cover both. That's why we picked it. And the good news is that all of the modules that we tried, they don't interfere with Apache's internal settings, internal directives that you could use to fight against slow attacks. There is another cool module that we found and played with. It's not really designed to fight against denial of service, but it could be used for it since it uses the honeypot project's list of offenders, so it could take those and basically blacklist them. So what can we do with the tool? As we talked a couple of minutes ago, you could use it for good as a QA tool, find all the limiters, fix them. It can be used for bad, and especially with the iterative analyzer that tries to figure out what really goes on with the server. If the service is really degrading, this becomes even worse. And of course, the ugly, which is the bad, multiplied by number of bots that you can buy. So let's go back to the tool and see what we probably miss and what could be done. And we need to understand what load balancers do with our analysis, because it could be skewed by because of different things that load balancer does to the traffic. We would like to figure out a cool way of integrating genetic algorithms into generating SQL wildcards and see how they behave, analyze the timing, and getting the feedback from the server and evolving the payload even more. We would also like to look at the state reset costs to see if crypto system abuses are really easy or not. They are easy probably, but would they be easy to integrate into the tool? And the automated attacker degradation measurement, as we talked before. So with that, I finish my talk. You could download the tool from GitHub and play with it. And if there are any questions, I will be happy to take them. And here are the references. Any questions?